using a power of -1.
Is no clicker, I take it?
This is, did this work for you, John?
Yeah, we're perfect.
Oh.
Make sure you give it back to her at the end.
That's beautiful.
Cool. Well, while it's loading, before I start, I just want to preface it with last night we presented and I basically tore this thing apart. So if the PowerPoint looks confusing, it's because it is. So I'm still working on things and there's bits and pieces, so just bear with me. So IDIS-1 is a wearable technology designed to improve construction safety. My name is Davis Markland and I'm the team leader of IDIS. And we want to change the way industrial safety is viewed. So this is Mike. Mike is a roofer. And as you can see, he's not wearing any safety equipment. Like Mike and many others like him, Mike and many others like him contribute to an over $8 billion industry in workers' compensation alone. Now, from that we can see that current safety procedure and protocol is not enough to keep him protected. So it begs the question, is there a way around that? So imagine I'm Mike for a minute, okay? I'm wearing a wearable safety device. It's taking current temperature and sensor, temperature, humidity, body heat, outside heat, and other biometric environmental data, and sending that to a server. The server then computes a risk factor. Now, if that risk factor is high enough, it's sent to my supervisor or foreman, who is then able to intervene and prevent this injury from happening. The key here is that we're not trying to physically protect the user. We're trying to predict an injury, and if we can predict the injury, we can prevent the injury from happening in the first place. Ooh. There we go. Okay. So we talked to over 50 construction workers and asked them questions like, what pains you most at the end of the day? How can we improve your life? And from that research and asking them other questions like, is this something you would be willing to wear? We found that this is something that has real value, and this is something that people would be interested in using if it can save lives, potentially. We also talked to workers' compensation lawyers. We talked to an workers' comp insurance company and a roofing owner. Now here we gained some really invaluable insight about the way the industry works and about our beachhead market, which is medium-sized roofing companies. We also learned a lot about the importance of insurance itself, and which actually led to us changing our business model. So here's our business model. We, IDIS, partner with insurance companies, and now they benefit because theoretically, once we get it tested, if this thing works, then they have reduced claims. So they have an incentive to promote this to their clients, the roofing companies, who then use it, and they have higher morale, higher productivity because they're using this thing. But they also get a reduced premium from the insurance company. Now, the roofing companies pay us directly. They buy this product from us, but they also pay us a monthly subscription fee. So it's a modified software as a service model. So our ask. We're looking for contacts in the construction and insurance industry. This is so we can test the product viability and get that initial data set so insurance companies would see this as something that they would potentially want to partner with. We're also want to keep doing customer research. We just had an awesome talk with an insurance company on Tuesday, and we learned so much, but we learned that we need to know even more. So we're looking for contacts there. We're also looking for mentors in the roofing and construction industry. So if this is something you're interested in, or if you know someone, or you are somebody who has experience in this, we'd love to hear any advice you have to say. God, I don't even remember your name right now. We're looking for electrical and computer engineers also. So if you or somebody you know is interested in joining a startup and has a lot of experience in electrical or computer engineers, we'd love to have you. Are there any questions?
Okay, now you wear this on your arm.
Yes.
Okay. Now that by your heartbeat, or does it say that you're in trouble, or how does it know that there's...
Yeah. Okay. So it monitors biometric, environmental, and motion data. Okay, those are metrics like heart rate, blood oxygen level, humidity, temperature, things like that. Now, the way that predicts if you're going to have an injury is based on your physiological state. If you're more fatigued, these will show indicators, and then we're able to actually predict whether you're going to have that injury. Does that explain your question?
Well, yes, it does, and that's what I thought, but I used to be an iron worker.
Okay.
And you're up on the beams, and you're nervous all the damn time.
Right.
So, I mean,
Right. So that's why it's also pattern tracking. So if you're like, yeah, if you're nervous like at any given, at one time, it's not going to be a problem. But if you're nervous all the time, and the motion analysis is important. So if you're hammering all day, that's going to greatly cause to your physical fatigue, and you'll be much more likely to make a mistake because you'll be tired. Yes.
So some of the biggest issues that are tracked in construction are fall prevention, right? Which I'm assuming is part of your roofer deal.
Yeah, that's why. Yeah, roofing.
Since he wasn't using any of his lanyards and fall protection, which is a common problem, do you guys have a way you can integrate verification of fall protection when a guy goes over 6 foot elevation?
Well, yeah. So fall protection, like you said, is very important to the process. But it's not 100%, obviously. There are over 80,000 injuries a year in construction.
Right.
So this is supposed to work hand in hand with fall protection. So if the fall protection doesn't work, this is going to be in the background 24, whenever you're on the job, monitoring your physical state and the environmental state, and actually predicting whether you're going to have that fall in the first place. Fall protection would theoretically be like a backup.
Sure.
That's what that answers your question.
Good.
Yes.
Yeah, I just want to follow up on that because it sounds like, naively thinking, a lot of the issues are really safety-related issues, the injuries that are the result of poor safety practices, not necessarily having high blood pressure that's going to get you to a heart attack phase. I don't know, out of those 80,000, how much are related to, just bad
Dumb decisions.
dumb decisions that you can't prevent with this ban, right?
Right.
So that's
Unless it measures IQ at the same time.
No, it doesn't.
Yeah.
Right. So if it is, there are obviously bad safety procedures, but a lot of the times, so you say nobody uses safety procedures. Just assume that, okay? You're consciously as a person going to make sure you're not going to want to fall. Nobody wants to fall, right? But you're more likely to fall if you're in a fatigued state of mind.
Yeah.
So you're correct that a lot of it is because there aren't safety procedures, but it's also true that you're not even going to fall in the first place. I mean, you're still going to be standing on whatever you're standing on. You're not going to fall in the first place if you're not in that state of mind or if you haven't been working all day. Now, this isn't 100%, but we're looking at an overall view. Yeah.
Me?
Yeah.
Okay. So my question also goes to these two guys is, because I know 2 people who are in construction, and I guess I would want to know the percentage of, what was the percentage of the people that you examined that fell as opposed to people that actually got hurt doing something? Because the people that I know that are in construction got physically hurt because they accidentally hammered their hand. The other one was carrying, a brick and dropped it onto the foot. So that has nothing to do with, you know what I'm saying? So what percentage of people that get hurt are an actual fall as opposed to actually again, not in regulation or just stupidity or making a wrong decision? Because you should have, I guess I want to know that hard number.
Right, okay. So falls themselves are one of OSHA's fatal 4, and they make up OSHA's fatal 4 make up about 20% of all injuries in the construction industry, which is a lot, but it's not all of them. So falls themselves make up about a quarter of that. So like 7% around there. And you're asking, how is that different from, say, somebody dropping on a brick? Well, if you drop a brick on your foot, it'd be the same sort of conditions under which you fall. Now, as I already explained, this is not 100%. We're not trying to prevent every injury from happening. But the underlying factor here is that if you drop a brick on your foot, if you fall from a building, if you, I don't know, put a nail in your hand, you're not going, generally speaking, it's going to be because you're in a state of mind, you're in a fatigued state of mind.
If you ask my boyfriend, he'll say it was the other guy's fault.
Yeah, there's one thing here, yeah. If somebody drops something on you, there's no way we can like help you there. It's more of a, yes.
I think what it is that helps managers make better decisions.
Yes.
Because they can put this on the roofer's arms, and the roofer can say, everybody's in a fatigue state of mind right now. Let's say you have 3 roofers, none of them should go up, let them have lunch and then go.
Okay.
Instead of worrying about them making, not the best choices.
I have 2 questions. I still don't understand the tipping point. So if this is really measuring biometric activity, if an alarm rings or something like that, when it's gone beyond the tipping point, does the worker, what's the correlation between that activity and the danger zone, so to speak? Does the worker stop? Do you have 30 seconds? Does the boss get an alarm? And then the second piece of that is, I would guess most construction workers and roofers work by the hour. So isn't there a disincentive? I would think the last thing these guys would want to do would be to be pulled off the job even temporarily because they're not going to get compensated for it.
Okay, so for your first question, actually I want to answer your second question first. So you're right, but it is a disincentive if they work by the hour. But it's also, if you're disabled and you, it's a precautionary incentive. So it's an disincentive to do it, but it's also an incentive to do it because if you don't and you do get injured, then it's a problem though. Yeah.
So your market is the managers, not the workers?
The market is the companies. The managers are just the people who would be preventing these injuries from happening.
So you're selling it to the owners then?
Yes, we're selling it to the owners. Yes.
Just trying to understand.
Have you been in contact with American Family Insurance?
We have not.
They have a venture capital arm
Okay.
called AmFam Ventures or something like that in Madison, where they are specifically looking for companies that that they can mentor or invest in and things like that have to do something related to insurance. And you may want to talk to them about this, especially if you're collecting this data and you can offer them some sort of and you can talk to them about some sort of cloud-based data product, where managers can learn from this and where they can learn from it and try to reduce their liabilities, across the board. Second thing I wanted to ask was, this sounds to me like an app that would be perfect, for example, for truck drivers.
Yeah.
It basically, if you get to a certain point of fatigue, it just, tells you you've got 5 minutes before we shut down the engine, find a safe parking place, and it sounds to me like that would be a much bigger and immediate market than something like the construction industry. Just a thought.
Yeah, we actually I was looking into that. We also looked into like mining, because that's a big one too, and manufacturing, but just through our research, the reasons and the accessibility in Milwaukee, that's why we went there with this one. Yeah.
Agree with the truck driver when I was thinking the exact same thing. Second thing I was thinking is, I think part of your sell on this, here's a suggestion. You want to basically be telling for the change management, workers, when you're at your best, you're fantastic. We want to make sure that you're always at your best.
Right.
Because I think if I'm the worker and I know my body, I know when I'm tired, don't put this thing on my arm and tell me when I'm tired.
Right.
Flip that conversation, say, you're absolutely right. When you're unstoppable, you're amazing, you're great at what you do. We want to make sure you're able to do that all the time at your best.
Okay.
So rather than say we're trying to find it when you're we're trying to tell you when you're going to make a stupid decision before you make it, which is what we're trying to do.
Yeah.
But I think it's flipping that conversation to the positive angle, because your biology is right. When you are fatigued, you make poor decisions. And for the on the substance abuse side, not getting any sleep is the exact same as being hungover. So if you can tell that somebody's fatigued from not having slept, substance abuse, you won't know it's substance abuse, but the signs will biometrically all be the same.
Okay.
So your science is solid, assuming you're doing long-range data tracking and you're doing, within this person, they're out of their typical sync.
Right. And I just want to say one thing. So over time, this is supposed to be a big data thing. So you have theoretically hundreds of devices across multiple sites, and they're always sending data to a server, which collects it. Now we're able to, as I mentioned earlier, we have an algorithm which would compute the risk factor. So that would actually improve over time the more data we have, if that clears things up for people.
In your slide, you showed, your very first slide, you showed that gentleman, Mike.
Yeah.
Okay. It led me to believe that you were gonna show me something that would tell me that he's gonna have a propensity to fall from that, looking at that. Worse versus, I would say, if you had a tired worker just at the end of the shift, hot, sweaty, just taking a break, that, because you're really talking about fatigue, that doesn't imply fatigue at all.
Okay.
I'm just saying, because you took us from, geez, we're gonna figure out how, that's gonna tell us he's not gonna fall, to now, oh, it's fatigue. So I think maybe possibly just using a different slide.
Yeah, and as I mentioned at the beginning, we're still we just tore this thing out last night, so we're still in the process of making this better. Yeah.
So, I appreciate this. I think what you're doing is really, really cool. It's bringing together a lot of interesting things in science. And on top of that, though, I see it's really a difficult thing to do because it's science, right? Internet of Things, software, big data, prediction. So, my question is, you're putting a bunch of inputs into an equation, you're going to get an output, you're trying to reduce risk. Do you have any idea how much potentially that could reduce the risk for insurance companies? Or how much because if I'm an insurance company, I want to know okay, where does the rubber meet the road? How much money are you going to save?
Exactly.
That's what I really
So at the moment, there's no way for us to know this. Okay. But the reason I asked, one of my first asks was test product viability, is so that we can just work with a construction company, have them wear it, I don't know, say for free, and just so we can get that data. Because until we get that data, we have no way of actually finding the relationship between data and preventative injuries. And then once we get that, is when we would pitch it to insurance companies, say, hey, is this something you're interested in? This is what we have. Yeah.
On your list of asks, do you have biologists or psychologists?
I do not.
I would suggest you have that.
Okay.
Because if you're going to correlate these two big pieces of data, you need somebody who can tell you how A creates or does not create B.
Okay.
And that's somebody who's going to need to look at this biometric data and tell you on a person's decision-making abilities. And it'll also give you a whole lot more insight into the proof that this is based on good science.
Okay.
I bet there's data out there related to athletic training, especially at the Olympic level or the professional athlete level, where they're doing biometrics. People are training hard. That might be a place.
There is quite a bit in the construction industry too.
Is there?
The safety managers, we manage the heck out of that.
Right.
I'm not a safety manager, but I know what they do.
Right.
They know the critical factors pretty well. So
None of it's biometric data, is it? There is nothing with that.
no, well, not really. Right now, it's more positional. Like one of the biggest issues is guys falling through holes.
Right.
So there are systems that guys wear
Right.
that are position sensitive, using beacons and things like that. So they don't drop through the hole that somebody just created. So you geofence that, and it knows when you get close to it, and then it alerts you on your vest. So,
So thank you very much, Davis, for stopping. And that does it for 1 Million Cups this week. We'll see you in 2 weeks. So we're taking next Wednesday off for the Thanksgiving holiday. So have a great Thanksgiving, everyone. Thanks.